Question 12 from the same topic, alternative to practical acid, alkali, and salt questions. A student investigated the reaction between aqueous sodium carbonate and two different solutions of a hydrochloric acid. So, solution A and B are hydrochloric acid. Why they refer them as A and B? It means they might have a different type of acid is same, but the concentration might be different. So the equation is given for sodium carbonate react with hydrochloric acid, give salt, water, and carbon dioxide. What will you observe when this reaction occur?
Effervescence.
Effervescence, because the gas is given off, so fizz bubbles, effervescence are there.
Solid dissolve.
Actually, it's aqueous sodium carbonate, so we won't see.
Okay, it will be dissolved.
It is already dissolved. They took a solution. Experiment 1, using a measuring cylinder, a 25 cm cube of a sodium carbonate solution was poured into a conical flask. So we took a conical flask, and in this conical flask, we took 25 cm cube of sodium carbonate. So sodium carbonate is Na2CO3. Then thymol pathylene indicator was added to conical flask. So drops of indicator added. A burette was filled up to a 0 mark and a solution of acid is there. So this time unknown solution is in a burette. Like the previous experiment, the unknown solution was there in a conical flask, but this time we have unknown solution in terms of concentration, not the type. It's an HCl, but with not a known concentration. So a burette was filled with HCl and use the burette. Initially it was 0 mark. Use the burette reading. The final reading. How much is the final reading? 13.2. So we have to complete this. So initial burette reading was 0.0. The final burette reading is 13.2 and the difference will be 13.2. So in the first experiment, how much HCl is used? 13.2 cm cube is used. Then the experiment was repeated. Experiment 1 was repeated using a methyl orange. Instead of, so we changed the type of indicator. We did not change anything. We just only changed the type of indicator. Methyl orange is red, orange in acidic solution, and it is yellow in alkaline solution. So as you can see, by changing the type of indicator can also affect the volume, like how much is needed. So burette was there, filled with solution A. This is also solution A of HCl, and the conical flask was having sodium carbonate 25 cm cube, but with a different indicator, that was methyl orange. So what is the initial burette reading here? Initial burette reading is 39.2 and the final burette reading is, sorry, initial is 12.8, final is 39.2. How much is the difference? 26.4. So 26.4 cm2. So you can see we did not change the concentration at, like we did not change the type of a solution. We did not change the reactant. Only thing what we changed the indicator. So by changing the indicator, it can also affect the amount of acid and alkali volume, the ratio. Because indicators are usually acids as well. So it can overall alter, and they're usually weak acids. So they can also alter how much volume of acid will completely react with an alkali. So it's type of the indicator will also affect how much you need. So this was 39.2, this one is 12.8, and the difference was 26.4. Then what color change was observed in the flask in experiment 2? Experiment 2, as they mentioned, they give you the hint, then in methyl orange is red in acidic and yellow in alkaline. So first sodium carbonate alkaline solution. So what is the original starting color? So starting color will be yellow, and then we are adding an acid until it reacts. So it will be orange, you can say, or red, orange. So starting color will be yellow. And the final color is orange or red orange. Acceptable both, as I mentioned. Then experiment 3 was done with the solution. Yeah, orange is neutral. The reason is that because once all of the alkali reacted with an acid, initially the solution will be neutral, or maybe you added like 2-3 drops extra, so then it will turn into red. That's why the color is written or red, orange, both are written like as a shade, because if a solution is neutral, it will be orange, but otherwise it will be red. Then experiment 3 was done. The experiment 3 was done, but this time we are using a solution B. So experiment 1 was repeat. So we use the same, as you can see, the first indicator, which was thymol pathylene, was used as an indicator. So we use the same indicator now, because experiment 1 was repeated using solution B. So in a conical flask, we took solution B of HCl, and the conical flask was filled with sodium carbonate 25 cm cube. So 25 cm cube of a sodium carbonate is there. What is the initial burette reading? You can use the screen annotation to complete. Final is 16.5, initial is 9.9, and how much is the difference? 6.6. So sodium carbonate, which was 25 cm cube, and we need only 6.6 cm cube for a complete reaction. This is experiment 3. This was experiment 2, and this is experiment 1. But you can see experiment 1 was repeated. So we will compare experiment 1 with experiment 3. So by looking at experiment 1 with experiment 3, can you identify which solution of HCl is more concentrated? Is it experiment A, like 1, which is A, and experiment 3? So experiment 3 is more concentrated because a smaller quantity can completely react with sodium thiosulfate. So B is more concentrated than A. What is the reason for that? Because a smaller quantity of this unknown solution can completely react with sodium thiosulfate. And what is the ratio here? Ratio of the volume, how much time it is more concentrated. So this is 6.6 and this was 3. Like when we are comparing the experiment 1, 3.2 and 6.6, we divide by smallest value, so 2:1. So experiment 1, we need double volume, and experiment 2, we need half volume. So when we compare the concentration, because the volume and concentration ratios are inverse, so the one which need a smaller volume, it means it has a high concentration. So this will have a twice concentration, and this will have, like, if this concentration is 1, this will be 2. Like it will have more moles in the small space, like same number of moles in a small space, and here in a large space there will be same moles. Is it clear, this part about comparison of the volume and concentration?
Yes, sir, clear.
Okay. So state one observation other than the color change. So other than the color change, what we observe? A carbonate is reacting with an acid. So fizz, bubbles, effervescence. Complete the sentence below. Experiment dash. Complete the sentence below. Experiment dash need the largest volume of hydrochloric acid for a color change. Which experiment need largest volume of a hydrochloric acid for a color change? Experiment 1, 2, or 3? Largest volume of a hydrochloric acid. Experiment 1, we need, yeah, 2 is the right answer. Because in experiment 1, we need 13.2. Experiment 2, we need 26.4. And experiment 3, we need 6.6. So which need the largest volume? It means experiment 2. What would be the more accurate method of measuring the volume of a sodium carbonate? If you want to, so because it was 25 cm cube, so the
Pipette.
pipette you can mention here. Yeah, continue. So pipette will be more accurate to measure the volume. That's right. What would be the effect on the result? Like in a titration experiment, remember one thing, when you're heating something, it won't affect the volumes. So what will be the effect on the result, if any, if the solution of a sodium carbonate were warm before adding hydrochloric acid? Like if we warm the solution before we are mixing them together, will it affect the result?
No effect,
No
because
effect is,
temperature will not affect the moles in the reactants.
yeah, because the equal, like we use the same number of the moles for the reaction, so it does not affect. Determine the ratio of the volume of a hydrochloric acid used in experiment 1 and 3. What is the ratio of the volume for 1 is to 3? Experiment 1 to 3. So experiment 1, it was 13.2. Experiment 3, it was 6.6. So what is the ratio of the volume? 2 is to 1. If, for example, you write 1 is to 2, example, then your answer will be wrong. Why? Because the question is experiment 1 and 3. So first it should be the volume of 1, and then the experiment volume of 3. And use your answer to H1, deduce how the concentration of A differ than B.
B is more concentrated as compared to A.
Yeah, B is more concentrated than A, or B is twice concentrated than A. Suggest a different method using a standard lab chemicals to determine which solution of a hydrochloric acid, A or B, is more concentrated. So how we can plan another method to know which solution of A or B is more concentrated?
We can check for temperature change, or for the salt formed, we can do crystallization or evaporate to dryness and check mass for each.
Yeah, that's also, or you can also measure the volume of the
For
gas.
the same volume, we can do this,
Yeah, there are
or
different
same
techniques,
volume
are there?
added.
There are different techniques can be, even electrolysis can also be done here. Like I will take equal amount of the two solutions and I will pass the
Check
current,
voltage.
check the brightness of the lamp. Voltage we are applying because it's an electrolytic cell. So electrolytic cell, we have the battery, we use the same battery, and we observe the brightness of the lamp. The solution in which the lamp is brighter, it means that is more concentrated. This is one method. Another thing, you can take equal amount of the two solutions A and B and add excess of the carbonate or metal and measure the volume of the gas. Why universal indicator is wrong? Because universal indicator is actually it's hard practical way. Universal indicators used to identify the pH of the solution, like which is having a higher pH or a lower pH, rather like a nature of a solution, rather than identifying the concentration of a solution. So we can add a metal here and collect the gas given off, the one which release a greater volume of a gas in a unit time. Or if you carry out a reaction, excess of a metal is added, in that case you record the volume of a gas, the one which give off a greater volume, it means that is more concentrated.
If it wasn't a carbonate, we can add noted volume of acid to noted volume of alkali or base, and then filter it, and then crystallize the filtrate, and
Yeah,
then check for mass for each.
Yeah, the one which produces, that's right. That's also correct. How you'll score 3 marks for the electrolysis experiment? You'll mention set up the electrolytic cell, that is 1 mark. Take equal volume of solution A and solution B, that is a second mark. Then compare the brightness of the lamp, that is a third. The one which is brighter, it is more constant. Like conclusion is scoring a 3rd mark.